Hello, fifth graders, and welcome again to remote learning. This is our week 3 math lesson. For today's math lesson, we are going to focus on finding the area of a rectangle. So the question for today is, how do you find the area of a rectangle? So our goal for this math lesson is that you will learn how to find the area of a rectangle. As you know, and have kind of gotten used to this by now, we will not have our typical normal visual learning bridge. I will be your visual learning bridge, so every once in a while I will stop and give you a couple of sample problems to practice with me. So let's get started.
All right, so before we begin practicing finding the area of a rectangle, we need to go over some important terms and ideas to help prepare us for this math lesson. So the first term I'm going to have us discuss is area. So what is area? Well, the area of a figure is the amount of surface it covers. In other words, it's the amount of space inside a figure. So for example, if we look at this picture here, of this garden. It's a rectangular shaped garden. The area of this garden is what is inside. So all of this space within this garden, that is the area. So area is always what's inside a figure. And in this case, because it's this rectangular garden, the area is what is inside. So this space right here. All right, so the next idea that we need to discuss is units of measurement. So when you measure things, there's always a unit. So for example, you might have a pencil that's 6 inches long. In that case, the unit would be inches. Or maybe you have a paper clip that's 4 centimeters long. In that case, the unit would be centimeters. When it comes to area, the units of measurement are more unique. Area is measured in square units because it's the number of square units you can fit in a figure. So for example, if we look at this rectangle that I have here, it is 5 inches long, 3 inches wide. Within this rectangle, you'll see a bunch of different squares. These are square units. As you can recall, area is the space within, inside a shape. So you use square units to figure out how many it will take to fill the inside of your shape. If I were to count these one by one, I would figure out that it took 15 square units to fill this rectangle. And in this case, I know the units, right? They're inches. So I could say that this rectangle, its area, the amount it took to fill the inside, was 15 square inches. Now there are a few ways you could write this, so let's explore a few. One way to write that rectangle had an area of 15 square inches is to just literally write it out word for word. So you could write 15 square inches. Now that's a bit of the long way to do it, so if you wanted to abbreviate it, you could write it this way: 15 square inches. So this is our abbreviation for square. This would be our abbreviation for inches. There's another way that's even quicker, which looks like this. This is still read as 15 square inches. Remember when we talked about that exponent, when we had our exponent unit, can also be read as squared? So this is still the same thing, 15 squared inches. It's the same as this, it's just a lot quicker to write it this way. So today, when you're working on your problems, I will let you choose which way you want to write the answer. All right, so another idea that we need to discuss is the formula for finding area. Depending on the shape, there are different formulas or strategies for finding area. Today, we're just going to focus on squares and rectangles. So the formula for finding the area of a rectangle or a square is always going to be length times width. Oftentimes you'll see it written this way. This is just the abbreviation to show that whenever you want to find the area of a square or rectangle, you do length times width. So if we have our rectangle, right, we know that area is inside, so you would always just take the length and the width, multiply the two together to end up with the area. Now, this strategy will help us out big time. So I want to refer back to the example that I had just showed you. So with this example, we had the square units already drawn out and labeled for us, so it was convenient. I could go through and count them one by one to figure out that it took 15 to fill up this space. Now, this one was convenient and easy to do because the square units were already there, and I could count them one by one if I wanted. But normally, when we have a square or rectangle, the square units are not there. So how do you figure out how many square units are within that space? We know they're there because the area is always square units, right? And in this case, they were labeled for us, so we could count them. But what do you do when they're not there and you can't count them one by one? And what if you don't want to count them one by one because that takes a while, right? Well, that's when you would just simply use our formula, length times width. So the length is 5 inches, the width is 3 inches. So you could do 5 times 3 to figure out that the area is 15 square inches, which is the same answer that I got when I counted them one by one, right? But it's a lot quicker to use our formula, length times width. Let's look at one more example. All right, so with this example, we have a rectangle and we know some of the measurements. The length is 9 inches, the width is 3 inches. And as you can see with this rectangle, my square units are not drawn out for me, so I can't count them one by one. I know they're there, they're just not drawn out for me. So in this case, I'm going to use our formula, length times width, to figure out the area of this rectangle. So the length is 9, the width is 3. So to solve this, I will simply do 9 times 3. So I'll write that out, 9 times 3. And 9 times 3 is 27. I know that the unit was inches, and when it comes to area, it's always square inches. So the area for this rectangle is, and I'm going to use my abbreviations here, 27 square inches. All right, now that you have watched me solve a problem, it's your turn to try one. So here is your problem. Your parents are getting their driveway paved. How much pavement will they need to cover the whole driveway? So they may contact a construction company, and then the construction company may ask, well, how many square feet is your driveway? So they can determine how much pavement they'll need to cover it. So in this case, you'll have to find the area of the driveway. The driveway is 20 feet wide and 40 feet long. So you will now try to find the area of this driveway. Remember, you can use the formula length times width. So go ahead and try that out. All right, so let's see how you did. So if the driveway is 20 feet wide and 40 feet long, and you want to find the area, you would simply do length times width. The length is 40. The width was 20. So we will have our problem 40 times 20. Now with this one, I can use my zeros trick, right? I can ignore the zeros for now and just see the problem as 4 times 2. Well, 4 times 2 is 8. And if I uncover my zeros, I see there were 2. So I'll add those 2 zeros to my answer. And we end up with 800. So if I look back at my problem here, I now know that the area of this driveway is 800. But I want to properly label it. So I know the unit was feet, and I know that area is always measured in square units. So it would be square feet. And I'm going to abbreviate mine. So the area of the driveway is 800 square feet. So far, all of the problems we have tried have had whole numbers as their sides. This time we're going to try a bit more challenging problem because the numbers are going to be mixed numbers instead. So here's our problem. I need to buy mulch to fill my flower garden. How much mulch will I need? So I may go to the landscaping company and tell them I need mulch, and their question may be, well, how many square feet is your garden? So I'd need to find the area. The length of my garden is going to be 6.5 feet, and the width is going to be 3 4/10 feet. So let's solve this problem. All right, so to solve this problem, because my flower garden was a rectangle, I'm going to use the formula length times width. My length was 6.5 feet, and my width was 3 4/10 feet. So I'm going to multiply the length by the width. So as you can tell, we have a mixed number being multiplied by a mixed number. So good thing we've been practicing this for the last couple of weeks during our remote learning lessons, because we know that the first step to multiplying a mixed number by a mixed number is to change these up to improper fractions. So we're going to make them mad. So we'll start with our first one. So we multiply the whole number by the denominator. So 6 times 2 is 12. Add that to the numerator, which would make it 13. And then denominator stays the same. So it gets changed to 13 over 2. All right, let's do it to our next mixed number. Multiply the whole number by the denominator. So 3 times 10 is 30. Add that to the numerator. That would be 4 more, so that would be 34. And then denominator stays the same. So 34 over 10. Now we know that when you multiply two fractions, you start by multiplying the numerators, then multiply the denominators. So let's start with our numerators. 13 times 34. Now that's not basic multiplication. It's a big problem, so I'm going to stack mine just to make sure that I'm being accurate. So here we go. I'll cover the tens place for now. 4 times 3 is 12. Write the 2, regroup the 1. 4 times 1 is 4, plus 1 more is 5. Cross that 1 off so I don't use it again. Moving on to the tens place, so ding, add that 0. 3 times 3 is 9, and 3 times 1 is 3. Next, we'll add our partial products. 2 plus 0 is 2. 5 plus 9 is 14. Write the 4, regroup the 1, and 1 plus 3 is 4. So now we know that 13 times 34 is 442. All right, our next step would be to multiply the denominator. So 2 times 10 is 20. Now we can't leave it that way, right? Because that is improper. So we have another step, which is to make it glad. So the G in glad stands for go divide. So we're going to do 442 divided by 20. Again, that's big division. So I'm going to stack mine and set it up off to the side here. So here we go. How many 20s go into 4? Well, it can't. How many 20s go into 44? 2 without going over. 2 times 20 is 40. And 44 minus 40 is 4. Next, we bring it on down. And then we repeat. How many times does 20 go into 42? Well, it can go in 2 times. 2 times 20 is 40. And 42 minus 40 is 2. Nothing left to bring down, so we end up with a remainder. So the L in glad stands for leave your answer as the whole number. The A stands for always put the remainder as the numerator. And D, denominator stays the same. Remember, our denominator was 20. So we end up with 22 and 2/20. Now hold on, there is one more step. We can simplify that, right? So 2 and 20 both have 2 in common as one of their factors. So I'm going to set mine up down here. Lots of work to show for this problem, to show how I can simplify it. So I could divide. 2 divided by 2 is 1. And then I'm going to do the same for the bottom, right? So 20 divided by 2 is 10. So really, 2/20 gets simplified to 1/10. So the final answer then would be 22 and 1/10. So if I go back to my problem, look at all that work for my flower garden, right? So now I know that the area of my garden, so I'll put area, is 22 and 1/10 square feet, right? My unit was feet, and I'm going to use my little abbreviation there. So it's 22 and 1/10 square feet. All right, now that you've watched me solve a problem, it's your turn. So here is your problem. During quarantine, your parents are giving you permission to put up wallpaper on one of your walls to create an accent wall. How fun! How much wallpaper will you need to cover the wall? So you're going to need to figure out how many square feet your wall is to make sure that when you purchase the wallpaper, you have enough. So here is your wall. It's 7.5 feet tall, that's our length there, and it's 3.5 feet wide. So to figure out how much wallpaper you will need to figure out how many square feet the wall is. So go ahead, try that out, and then we will see how you do. All right, let's check your work. So to find the area of your wall, you'd have to do length times width. 7.5 times 3 1/3. To begin, you need to make these improper by making them mad. So we'll do 7 times 2, which is 14. Add one more, that would make 15. Denominator stays the same, so 15 over 2. Let's do the same for the next mixed number. 3 times 3 is 9, plus 1 more is 10, so we get 10/3. Our next step would be to multiply the numerators and then the denominators. So 15 times 10, I can use a trick for this one. Cover the 0. 15 times 1 is 15, and then I'll just add the 0 in, which makes 150. And then the denominators, 2 times 3, which is 6. So we get 150 over 6. Now we can't leave it like that, so we're going to make it glad. The G in glad stands for go divide. So 150 divided by 6. So I'll set my problem up down here and give myself a little bit more room. So here we go. How many times does 6 go into 1? It can't. How many times does 6 go into 15? 2 times without going over. 2 times 6 is 12. And 15 minus 12 is 3. Bring down the 0. And then we ask, how many times does 6 go into 30? 5 times. 5 times 6 is 30. And 30 minus 30 is 0. So we end up with a whole number. So 150 divided by 6 is 25. So that would be our final answer. So if we go back to our wallpaper example, that means this wall, its area, is going to be 25 square feet. And there's my label, 25 square feet. Okay, so far, all of the problems we have solved have been a perfect rectangular shape. We're now going to try some problems that have what we call irregular shapes. So here's our problem. I want to tile the floor of my kitchen. To make sure I purchase enough tiles to cover my kitchen floor, I will need to know how many square feet my kitchen is. How many square feet is my kitchen? So with this problem, I still want to be able to do length times width. That does not mean I can just randomly pick numbers and think, oh, you know what, I think I'll do 4 times 2 and that'll give me my area. That's not what we want to do. We can still use length times width if we are able to split this shape up into rectangles, because remember, length times width is what we use for rectangles. So what I'm going to do to my irregular shape is see if I can split it into more than one rectangle. Which when I look here, I think it's possible to do that here. So I'm going to draw some dashed lines to split this up. So now you see we have one rectangle here and a second one here. So if I focus on just this rectangle here, to find the area, I would do length times width, 5 times 2. Well, 5 times 2 is 10, so the area of this rectangle is 10 squared feet. All right, we're going to ignore this rectangle for now and move on to our second one. Again, we would do length times width, so 4 times 2, and 4 times 2 is 8. So the area for this rectangle is 8 square feet. Now, if I want to find the area of the entire kitchen floor, then what I would need to do is combine these. So combine the 10 feet and the 8 feet. So to combine those, we can just add. So I will stack my problem. So 10 plus the 8 would be 18. So that means the area of my kitchen would be 18 square feet as our final answer. All right, now that you have watched me find the area of an irregular shape, it's your turn. So here's your problem. You decide to help your family build a deck. What is the area of your deck? So go ahead, try this out, and then we'll see how you do. Okay, let's see how you did. So hopefully you were able to determine that you needed to split this irregular shape into two separate parts. So I would have split it right along this spot here to create two separate rectangles. So I'm going to start with this rectangle. So we have a length of 10 feet. The width is 6 feet. So we're going to do 10 times 6. 10 times 6 is 60. So the area of this rectangle is 60 square feet. All right, moving on to the second rectangle. So we have 4 and 8. So we'll do 4 times 8, which is 32. So the area of this rectangle is 32 square feet. So to find the area of the entire deck, we're going to combine the two, 60 and 32. To combine them, we can just add the two. So I will stack those off to the side here. So we'll do 60 plus the 32. And here we go. 0 plus 2 is 2, and 6 plus 3 is 9. So the area of this deck is 92 square feet as our final answer. So to wrap up our video, I am ending it with a question. What is area? Tell me in your own words.
All right, fifth graders, that is it for this lesson. I hope you've got enough practice and feel comfortable and confident to go to Seesaw and solve some more independent practice problems. Good luck and have fun.